Welcome back to the deep dive. So lots of you have asked how your Android TV manages to feel, well, pretty smooth most of the time, even when it only seems to have about 2 gigabytes of RAM.
Yeah, it's a great question. How does it juggle streaming, maybe some apps, keep the
Yeah,
menu responsive? It feels like it shouldn't work that well sometimes.
exactly. So we've dug into a bunch of details on Android TV's memory management. We want to unpack the tricks it uses.
Mm-hmm. Uncover the secrets behind that balancing act. It seems like magic, but it's actually some clever engineering.
Right, like how does it handle Netflix, maybe a light game, and flip back to the menu without completely crashing? Let's get into it.
Okay, so the first thing to grasp is that it's not just one type of memory. There's kind of a trio working together.
Okay. So you've got the main RAM first, I assume.
Exactly. Random access memory, that's the super fast stuff, like your immediate workspace, whatever app you're using, the operating system. It all needs that quick access.
But it's limited, especially on TVs. Cost is a big factor there, right?
Definitely. So that's why they bring in Zeram.
ZAM. Okay, I've heard of this. This is the compressed RAM thing, like squashing things down to fit more in the same space.
You got it. It's a specific chunk of your main RAM that the system uses to store compressed data. Think of it like virtual memory, but in RAM, not on the slower storage.
So it's faster than using the actual storage drive as swap space, which Android TV doesn't really do anyway to avoid wearing it out.
Precisely. It's a trade-off, though. Compressing and decompressing that data takes CPU cycles.
Okay. But it's worth it to effectively get more usable RAM.
Mm.
And the third part of the trio is just the regular storage.
Yep, the internal storage. That's for the OS itself, your installed apps, downloads, all the permanent stuff. But crucially, not used for active memory swapping. That makes RAM and especially ZRAM super important.
Okay, so we have these memory types. How does Android TV actually manage what goes where, especially when things get busy?
Well, Android itself has a couple of core mechanisms. First up is K-swapped.
K-swapped sounds like a system process.
It is. It runs in the background, kind of like a low-key cleaner. When RAM starts getting a bit full, swapped wakes up.
And what does it do? Tidy up?
Sort of. It looks for memory pages that are clean, meaning they're just copies of data already saved to storage, and it can just discard those to free up RAM.
Okay, that makes sense. Easy win.
And it also looks for dirty pages, stuff that's been changed or hasn't been saved, and compresses that data into ZRAM. It's the first line of defense trying to keep things flowing.
But what if K-swap can't keep up? If you're really pushing the system?
That's when the heavy hitter comes in, the low memory killer, or LMK.
Low memory killer. Sounds final.
It's definitely more aggressive. If K-swapped isn't freeing up enough RAM quickly enough, the LMK starts terminating processes, killing apps, basically.
Whoa. How does it decide what to kill? Surely it doesn't just randomly shut down my Netflix stream.
No, definitely not. It's quite smart about it. It uses something called an UMAD score, out-of-memory adjustment score, for each process.
Okay, so a higher score means more likely to get killed.
Exactly. Background apps you haven't used in a while, high score, they're first on the chopping block, then maybe cached app services.
And the app I'm actively watching or using.
That gets the lowest score. It's the absolute last resort. Same for critical system processes. The LMK is designed to protect your immediate experience above all else.
Phew, okay. That's reassuring. Is there anything else involved?
Yeah, there's also a mechanism called on-to-memory. This is more collaborative.
Collaborative. How so?
The system can send a signal to apps basically saying, hey, memory's getting a bit tight. Could you maybe clean up after yourself a little?
Huh. Like a polite nudge.
Pretty much. And well-behaved apps will respond by releasing resources they don't strictly need, right? Then maybe caches or UI elements that aren't visible.
So good apps help prevent the LMK from even needing to step in.
That's the idea. It leads to a smoother experience overall because apps aren't just abruptly terminated.
So Android TV uses these standard Android tools, K-swapped LMK, onto memory. But does it do anything specific for the TV environment?
It does. It really leans into prioritizing that foreground app, the video player, the game, whatever you're focused on. That gets preferential CPU and memory access.
Makes sense for a TV. And this RAM is probably even more critical on a TV with typically less RAM than a phone.
Absolutely. That compression is key to stretching the limited physical RAM. And background processes are generally much more restricted than on a phone.
Right. You don't usually need lots of things running actively in the background on a TV.
Exactly. Android TV limits what background apps can do by default. There's even a setting in developer options, the background process limit, that lets users restrict it further.
Oh, where's that?
You have to enable developer options first, usually by tapping the build number in the settings menu multiple times. But messing with that setting can sometimes break notifications or app functionality, so proceed with caution.
Good warning. So developers are encouraged to be smarter about background work too.
Yes, using things like Work Manager to schedule tasks efficiently, rather than having services running constantly and draining RAM.
Okay, let's talk streaming. Watching high-def video, that uses a fair bit of memory for buffering, right?
It does. Streaming apps need to buffer ahead, preload chunks of video so playback stays smooth, even if your internet connection hiccups for a second.
But they can't buffer too much, or they'd hog all the RAM.
It's a balancing act. They need enough buffer for smooth playback, but not so much that it impacts the system's ability to run other apps or keep the UI responsive. There are even recommendations for buffer sizes based on device RAM and stream resolution.
And what about more demanding apps, like, say, complex games? Can 2 GB handle that?
It can be a stretch. For really high-end games or heavy multitasking, 2 GB is quite limiting. You might notice the system getting aggressive with the LNK, maybe apps reloading more often, or even some visible lag or stutter.
So the whole Android TV system is kind of lean by design, optimized for this specific use case.
Very much so. The interface, the lean-back library, it's all tailored for TV viewing. Historically, Android TV actually had lower minimum RAM requirements than standard Android.
How does it compare to other smart TV operating systems, like Tizen or WebOS? Are they lighter?
They often are considered quite lightweight and optimized for their specific hardware, but the trade-off is usually the app ecosystem. Android TV's strength is the huge Google Play Store library.
Right. So practically speaking, what difference does more RAM make? Say, comparing a 2 GB TV to one with 4 GB.
You generally see smoother multitasking, apps load faster, and demanding apps run better. A jump from 1 GB, which really struggles, to 2 GB is significant. But going to 4 GB, like on some newer devices, often provides an even snappier feel.
And users do report differences, right? Like maybe Kodi runs smoother on higher RAM devices.
Yeah, you definitely see anecdotal reports of lag or apps needing to reload more on 2 GB devices, especially with heavy use, compared to those with more RAM.
Interesting that Google recently lowered the minimum requirement again, allowing 1 GB for some 1080p devices running Google TV.
Yes, it makes devices cheaper, but there's definitely a potential trade-off in real-world performance and user experience. You have to wonder how smooth that will actually feel.
Are there things we, as users, can do to help our potentially struggling 2 GB TVs? Any tips?
Yeah, the usual suspects, really.
Yeah.
Uninstall apps you genuinely don't use. They might have background components eating RAM.
Good point. Clear the cache sometimes.
Clearing cache and occasionally data for misbehaving apps can help. Disable features you don't need, like maybe certain manufacturer-specific background services if possible.
What about restarting? Does the classic turn it off and on again work?
Honestly, yes. A regular restart clears out temporary files and closes background processes, giving you a fresh start, maybe once a week or so.
Okay. And maybe using external storage for apps if your TV supports it.
That can help free up internal storage, though it doesn't directly add RAM. Disabling animations and developer options can make it feel faster, too.
And I guess the nuclear option is a factory reset if things get really bad.
That's the last resort, yeah. But sometimes it's necessary. Just be aware of the limitations with 2 GB. You might still see occasional lag or app crashes with very heavy apps, no matter what you do.
So wrapping up, even though 2 GB sounds tight, Android TV uses this pretty clever mix of memory types, RAM, SRAM, and management strategies like K-swapped and the LMK to prioritize what you're doing.
Exactly. It's constantly juggling, compressing, and sometimes killing less important stuff to keep your main experience, hopefully, smooth. It's all about maximizing those limited resources.
It really is quite sophisticated under the hood. Makes you wonder what's next, doesn't it?
Totally. How might memory management evolve? Could future TVs get even smarter, maybe predictively loading apps or content into memory based on your habits before you even select them? Imagine that level of optimization.
Ooh, that's a cool thought. Proactive memory management. Well, we hope this dive into the memory workings of your Android TV was illuminating.
Yeah, hopefully it clears things up a bit.
Let us know what other tech mysteries you're curious about. Maybe your question will spark our next deep dive.